Good morning everyone, my name is Patliputra from page 1 and today I am here to explain the concept of set theory. First of all, we'll know what is a set theory. A set is a collection of well-defined elements, and when I say well-defined elements, it means a collection of elements. For example, if I give an example of set A is equals to 1, 2, 3, 4. So here we can see the common relation between the elements are that there is a difference of 1 in each element. Moving on to the rules we follow while representing a set are, a set is represented by a mid bracket and the elements are written under mid bracket and separated by comma. Second, orders can be interchanged, repetition of elements are not allowed, and the last is we have to write set in capital letter and all the letters in small letter. Now there are two methods we can represent set. The first is roster or tabular or listing method, and second is set builder method. So in roster method, we directly write collection of elements. For example, what I have written here 1, 2, 3, 4 is an example of roster method. But in set builder method, it's a slight difference that we write a common relation between elements. For example, A is equals to X such that A is equals to X such that 1 less than equals to X less than equals to 20 for all value of X belongs to natural number. This is an example of set builder method. Here it can be noted that every set cannot be represented in roster method, but every set can be written in set builder method. Moving on to types of set. Empty set. Empty set, as the name suggests, empty set are the sets in which there is no element, and we represent empty set by 5, by middle bracket or 5. These are the methods we can represent empty set. Non-empty set, if there is element present in a set, for example 1, 2, 3, 4. Singleton set, any set is called singleton set if it has one element. Pair of set if it has two elements. Pair of set if it has two elements. Multiple set if it has more than two elements. Infinite set if it has countable number of elements, and infinite set if it has uncountable number of elements. Now we are moving to subset. Now we will move to subset. So the definition of subset is, let A and B be two sets. If each element of set B lies in set A, then we say that B is subset of A and A is superset of B. For example, if I take an example of A is equals to 1, 2, 3, 4, 5, 6, 7, and B is equals to 2, 4, 6. So here we can see that all those elements which are present in B lies in set A. So here we can see that B subset A, and if we have to do the converse, A superset B. Now moving on to proper set, just slight difference between subset and proper subset, that all the elements of B lies in set A, but there is at least one element which is not present in set B. And the formula for finding subset is 2 to the power n, and formula for finding proper subset is 2 to the power n minus 1. So again, it can be noted that every every proper set can also be written in subset, but every subset is not a proper set. Now moving on to power set. Any set is called power set if it is subset of all possible sets. For example, I would like to give the example of set A is equals to 1, 2, 3. Now power set is represented by P of A. First of all, we write now empty set that is 5, and all the single elements 1, 2, 3, and now we'll write the pair 1, 2, and lastly 1, 2, 3. And there's also a formula for finding power set, that is 2 to the power n. So we have 3 elements, so 2 to the power. So this is power set. This is an example of power set. Moving on to operations of set, there are basically 3 types of operation. First is union, second is intersection, and third is difference. In difference, it is subdivided between symmetric difference and complement. So first of all, we'll know what is union. A union, let A and B be two sets. Then element present in set A or B or both is called union. It is basically represented by A union B. This is the symbol to represent union. For example, A is equals to and B is equals to so here A union B will be 1, 2, 3, 4, 5. The mathematical definition of union is X such that X belongs to A or X belongs to B. Moving on to intersection, let A and B be two sets. If there is common element between set A and B, it is called intersection. It is just opposite of union, A intersection B. A is 1, 2, 3, 4, 5 and B is 2 and 5. So the common elements between A intersection B are, so that 2 and 5 is present in A, so 2 and 5 will be A intersection B. The mathematical definition of intersection is X such that X belongs to A and X belongs to B. Moving on to difference. Let difference can also be represented by A by B or A minus B. Let A and B be two sets. All those elements which is present in A does not lies in B is called difference, and it is represented by A minus B. A minus B or A by B. The mathematical definition of difference is X such that X belongs to A and X does not belongs to B. And the formula for finding A minus B is A intersection B ka complement. We'll know what is complement further. Moving on to symmetric difference. Let A and B be two sets. Then the element present in A or B, but not both A and B, is called symmetric difference. The formula for finding symmetric, this is a symbol to represent symmetric difference. And what the mathematical formula is X such that X belongs to A and X belongs to B, but X does not belong to A intersection B. A intersection B. That is the common relation between the elements. That is the mathematical definition of intersection B. And to find asymmetric difference B, the formula is A minus B union B minus A. We can find symmetric difference. Moving on to universal set, as the name suggests, any set is called universal set if it is a superset of all set, and it is represented by U. Now, the last operation, that is complement. So let U be the universal set and A be any set. So U minus A is complement of any set. So U minus A. This is the complement. Now the mathematical definition is X such that X belongs to U and X does not belongs to A. And here it can be noted that A is not equals to A ka complement. After this, there are 7 forms we can write in operation by which we can solve problems. But moving on to next, I will start the last topic, which is Cartesian product. So let A and B be two sets. Then all the ordered pair of X comma Y in which X belongs to A and Y belongs to B is called Cartesian product. It is represented by A cross B. And the mathematical definition is X comma Y such that X belongs to A and X belongs to B. This is the mathematical definition of Cartesian product of A cross B. And we can note here that A cross B is not equals to B cross A. And if you want to make it equal, then A and B should be equal. If you want these to be equal, then A is equals to B. And if there are elements in A and elements in B, then to find
yes, sir.
And to find Cartesian product, M into N is the formula. M into N or M dot N is the formula. That's all. Thank you.